I think now he would be knowing all aspects of installing a power plant. So here you can see that the details of the power plant, what we have sitting quietly in the new faculty block of mechanical department, second floor. You can always visit. So it's a 10 kilowatt peak power plant, and the inverter is it's connected to the internet, so you can see online. So right now it is producing 5.1 kilowatt. That is the power it is produced. And so far, from the installation of October 30th, 2023, 16,390 units of electricity is produced. And the cost is the estimated savings by supplying that to the grid of NNDT is 1.95 lakhs. So we have put up, a lot of other problems we face. This while drafting the specification, we said that lightning arrestor and the earthing is to be according to the IS specification. So the supplier thought that it would escape by putting some rod inside, but we never accepted it. We asked them to install as per IS. So finally, we managed to install everything as per IS before we really passed the bill. So in that way, we have had a lot of experience in installing this power plant. Also, Uday Kumar was involved in the ammonia production plant. He visited personally to the supplier every time, so that consciously he brought the best equipment. I think that will be useful for completion of the project in a very good way. So with these things, I welcome Kumaresan, Dean Faculty Welfare, who is very instrumental in helping the faculties to take up these kind of projects. So he is very, very supportive. He also belongs to electrical department, so he would be, since part of the project is energy production, he is connected with that. I also welcome John Wu, the professor who is joining online, Chemical and Biomedical Engineering, West Virginia University. Welcome you, sir.
Thank you.
With this, the technology tools, we are able to get the best resource person. I think that the interaction with the experts will be immensely useful for the candidates who have registered and attending this course. With this few words, I once again welcome all of you. Thank you.
Thank you, sir, for your warm welcome and inspiring words. Now, as a token of appreciation for their support and guidance, we would like to honor our distinguished guests with mementos. Now, I request Dr. K. Paneerselvam, sir, to felicitate Dr. N. Kumaresan, sir, with a memento. Also, I request our course coordinator, Dr. R. Anand, sir, to present a memento to our respected head of the department. Thank you, sir. Next, I would like to invite our course coordinator, Dr. R. Anand, sir, who is the driving force behind this course. Known for his expertise in sustainable energy, he has been instrumental in shaping today's program. Now, I request Dr. R. Anand, sir, to give introduction about this program.
Morning, everyone. It's my privilege to welcome you on and off the dais to the inaugural session of the GIAN course titled Green Ammonia, a key player in carbon-free energy revolution. I am thrilled to have collaborated with Professor John Wu, a distinguished professor from West Virginia University, USA, who has generously agreed to contribute his expertise to evaluate this course. Upon approach, he was immediately agreed upon taking this course to the next level, bringing invaluable insights and global perspective to the learning expertise. First, let me briefly introduce the GIAN initiative. The Global Initiative of Academic Network GIAN is a visionary program by the Government of India aimed at strengthening academic courses in our country. By facilitating collaboration with renowned international and national experts, GIAN seeks to bridge knowledge gaps, foster innovation, and accelerate India's academic and technological achievements. This platform empowers students, researchers, and professionals to gain global perspective while addressing local challenges. Coming to this course, Green Ammonia, a key player in carbon-free energy revolution, it highlights one of the most exciting frontiers in sustainable energy. As the world transitions towards carbon neutral free, green ammonia is emerging as a critical enabler. Unlike its conventional counterpart, green ammonia is synthesized using renewable energy sources like solar, wind, hydro, geo, ensuring carbon-free production process. What makes green ammonia unique is its versatility. It can act as both an energy carrier and a hydrogen storage medium, making it invaluable for sectors that are hard to decarbonize, such as heavy industries and long-haul transportation. This comprehensive course is meticulously designed to provide an in-depth understanding of green ammonia and its role in carbon-free revolution. The curriculum includes 25 lectures and 15 tutorials, integrating both theoretical and practical learning approaches. The planned lectures will cover several integrated topics, starting with drawbacks and challenges of traditional ammonia generation, which relies heavily on natural gas and contributes significantly to carbon emissions. Focusing on sustainable approaches to ammonia synthesis, such as plasma-based techniques. Plasma-assisted ammonia synthesis presents an innovative solution, offering the potential for more energy-efficient process compared to conventional methods. The lectures will explore chemistry behind ammonia formation, including complexities of nitrogen fixation, which is traditionally energy-intensive and requires high temperature and pressures. Key highlights of the course are research-oriented and future trends, guiding participants through emerging challenges and opportunities in green ammonia synthesis. The course includes lab sessions on hands-on experience, allowing direct engagement with experimental setup for practical insights into synthesis process. Field visits to the operational facilities at NITT, case studies is also included in this course. I thank each one of you for your interest in joining this course and participating in this course. Together, let us delve into this fascinating journey of discovery, innovation, and collaboration to build a sustainable future. Thank you very much.
Thank you, sir, for giving us an overview of this impactful program. Now it's my honor to invite a compassionate leader who continuously strives to enhance the welfare and professional growth of our faculty members of NIT District. Now I request Dr. N. Kumaresan, sir, Dean of Faculty Welfare, for giving the presidential address.
Professor Jianli, West Virginia University, USA, Dr. Pandirselvam, HOD of Mechanical Engineering, Dr. Anand, Course Coordinator, Deans, Faculty Members, and my dear participants. Good morning to all of you. Indeed, as Professor Pandirselvam mentioned, so wherever possible, we should use the renewable energy and try to reduce the use of the power generated from fossil fuels. So that way we can reduce the carbon dioxide emission. So last week I attended one of the workshop in Chennai. The estimate of the renewable energy, two key players, one is the solar plant and another one is wind energy. So if we use in our country only the 3% of the barren land, the solar plant installation. So the capacity what we have is something like 1000 gigawatt plus. So which is equal to 2 to 2.5 times of the total capacity what we have at present in our country. Similarly, wind energy in 80s, the estimation was something like 47 gigawatt. Now we have achieved it. But as the R&D activities improved in terms of the electrical side, mechanical side, in particular the material sides, now the capability in our country through wind energy is something like again 1000 gigawatt plus. So it gives a clear indication that we can do the generation of power only using the renewables. Fine. Now where is the problem? So the problem is with respect to the renewable energy, we know that it is not like conventional power plant. It's intermittent in nature and it is not continuous. So at times it will have the full output and the next instant, so it will have the even zero output also. And now it gives the challenge for us to manage from the electrical side. So that's what we concentrate from the electrical engineering side. And from the electrical engineering, we do a lot of power electronic controllers, where our professor mentioned the inverter and how to have that connecting that solar power output to the grid or to the standalone power supply. So interestingly, Professor Pandiselvam also mentioned that the earthing is the biggest issue when we go for such power plant. At least the power plant what we have installed in the mechanical department is on land. So we can do that earthing. Now the people are thinking of floating solar power plant. So doing the earthing for such floating solar power plant is again the biggest challenge. We can come across all the challenges. Now even the people, they think of installing the solar power plant in the other universe moon and transmit the power from there to the land. And companies working on that. Interestingly, all the material needed for making the solar plant, making the power converters, everything is available in the moon. But how to carry out installation of such plant in the moon is idea. What they are thinking is they will train the robots. They will send with few panels, power electronic converters with robots, and they will install robots to install the plant solar PV panels as well as power converters, generate the power. Then again they have to make the panels and power electronic converters, etc., what the material available within the moon, and improve upon the plant. The second challenge is transmitting the power from that place to the land, earth. So those are all things it's going, it's really now it looks like it's all imaginary. In future, all the things will come into the reality. Now one part is the generation of the power. It is available. The second part is, as I already told you, with respect to the renewables, it's not constant, it's variable nature. And the biggest thrust area is storage. So I believe this course concentrate on the storage of the electricity in other forms. And when you use the storage in the form of ammonia, using the renewables, I guess they call it as green ammonia. So now the government also working on the different storage mechanism. And I'm sure that some of you would have known that they're thinking of putting more number of pumped storage hydro plants, because storing that potential energy using maybe the green ammonia and the pumped storage hydro plants, those things are more efficient than the batteries. Somehow we have to reduce the usage of batteries, and wherever possible, big power plant, it's possible. All the things what we are talking of are possible. So I'm sure this course will give the participants on in-depth knowledge in terms of how to get the ammonia from the renewable energy, green ammonia, And maybe the second point, few experts may give how to convert the stored energy into the usable energy, directly the heat, or converting into the electrical side, etc., etc. So it's really interdisciplinary in nature. And it's again surprising. It's a mechanical engineering department. The expert is from the chemical engineering, and they are doing the energy harvesting or energy storage using the ammonia or hydrogen and so on. So from the institute side, as Professor mentioned, we always support the faculty members for running it with the aim of, earlier we had that TRL level a little bit showing the concept and making the prototype in the laboratory. Now our aim is from the laboratory to prototype. So next level we are moving, our institute is moving, and from the institute side as well as the Ministry of Education, Government of India, they are all supporting to have that making the laboratory to the product, the commercialization of the products, and this course will give some insight into investing or making or creating some investor or the company startups. If that is the out of the outcome of this course, it's really good, and that's the aim of our country we are looking for, and the institute is supportive for all the things. So I'm sure Dr. Anand and with his team, they would have planned along with the foreign faculty, they would have planned the 1 week course, 2 week course with what is needed for the participants in this area. So my appeal is please attend, and whenever they are having that laboratory courses, pay more attention on that, because Professor mentioned it's the installation of the solar plant. It involves many number of other side of the engineering what we know. So that's essential to have that overall product development. So make use of that whenever the laboratory is there, fully use that time, and the theory also. So you should understand and improve upon your the TRL level capability. And I wish that this course will be of grand success. Thank you.
Thank you, sir, for sharing your encouraging words. Now, we are incredibly honored to have with us today our chief guest, Professor Jianli from West Virginia University, USA. Professor Hu, sir, is internationally recognized for his groundbreaking research in chemical and biomedical engineering, especially in sustainable energy. His dedication to advancing green technologies has been inspiring to researchers and students worldwide. Now, it's my pleasure to welcome Professor Jianli sir to address the gathering.
Thank you. Good morning, everyone. I'm so honored to have the opportunity to give a lecture at the NIT. First, I have to apologize that I will not be able to make a trip to the NIT because of the research load, and also I'm also teaching in this semester. But I'm really glad that Dr. Anand put this online teaching allow me to teach remotely. So can everyone hear me? I want to make sure you can hear me.
Yes.
Okay. Yeah. So I think this is a very good courses putting together by Dr. Anand and also the NIT. I think the several speakers already mentioned about the green ammonia. It's very important. So in this courses, Dr. Anand and I, when we put the lecture topic together, we have spend a lot of thought behind. So essentially, ammonia industry has been around for over 111 years, started from paper wash. So we are going to discuss about the traditional way to make ammonia, but the focus will be on the unconventional way to make ammonia. With today's technology, so we are able to produce ammonia at a much mild condition rather than paper wash, high pressure, high temperature. For example, we are going to talk about the microwave catalysis, electrochemical, chemical looping, and also plasma chemistry. So this is really the very interesting courses. And back to the here at West Virginia University, we are heavily funded by the United States Department of Energy on ammonia synthesis. So we have been working on this topic for over 10 years in collaboration with national laboratory industry such as Shell and also the other major industry company like Coke Fertilizer. So one of the reasons I like to teach these courses, my background is I work for major U.S. companies such as BP Oil and Coke industry. Coke industry is the largest private company. Oh, Coke industry owns the second largest ammonia plant in the North America. So I do have a real world experience in the refining and also ammonia. So in the classroom, I want to share the industrial experience and then to compare what theory we teach in the classroom, how that practice in the industry, the real world plant. So a couple of things I would like to mention. This is really very interesting courses putting together by Dr. Anand, because this course require a lot of the interdisciplinary knowledge, not only chemistry, chemical engineer. By training, I'm a chemical engineer, and also requires a lot of material science, mechanical engineer, even physics, plasma. So by doing unconventional way ammonia synthesis. So one of the speakers just mentioned about the green ammonia required renewable power, solar and wind. We all know solar and wind are intermittent by nature. However, the Haber-Bosch plant today designed 24/7 operation, so you cannot start or shut down Haber-Bosch plant on daily basis. But the technology or the science behind of the technology we are going to lecture, we basically can design the process or equipment that can operate on the quick startup shutdown. So I'm not going to overemphasize what we are lecture, because we have the 2 weeks to discuss about the different topic, and then at the end I'm very happy to work with the students, and then I hope after the courses, some of you students will continue your career in decarbonization of the industry. Thank you.
Thank you, sir, for your valuable insights. To formally express our gratitude, now I invite Mr. A. Uday Kumar, Research Scholar, NIT Trichy, to deliver the vote of thanks.
Good morning to everyone present here. I feel deeply honored and privileged to have opportunity to deliver a vote of thanks for today's inaugural session of the GIAN course, Green Ammonia, a key player in the carbon-free energy revolution. First and foremost, I extend my heartfelt gratitude to our beloved director, Dr. G. Aguila, for her visionary leadership and unwavering support to providing the platform for transformative learning experience. Your commitment to foster the global collaboration and academic excellence has made this remarkable course possible. Thank you, ma'am. I'm immensely grateful to our distinguished chief guest, Professor Jianli, for his inspiring and thought-provoking address. Your expertise in ammonia synthesis and nitrogen fixation is laid strong foundation for the course, and your insights will undoubtedly guide us in exploring innovative pathway in green ammonia technology. My sincere thanks to our respected Dean Faculty Welfare, Dr. Kumaresan sir, for governing today's session and delivering an encouraging presidential address. Your support has instrumental in enabling courses of such academic values. Thank you, sir. A special note of thanks to our Dean RMC, Dr. V. Sankaranarayanan, for his motivating words, for his continuous support and bridge between academic and industry. He is giving continuous support for bringing our research to industry. And warm thanks to Dr. K. Panniselvam, head of the department, for Further, gracious welcome and setting the perfect tone for today's event. Your forward-thinking approach inspires and equips students to face future challenges with advanced skills and knowledge. Thank you for your dedication and valuable contribution, sir. I extend my deepest gratitude to our committed course coordinator, Dr. R. Anand, for his tireless efforts in conceptualization and organizing this course. Your passion for promoting waste-free and carbon-free revolution and circular economy is truly admirable. Thank you, sir. My special thanks to computer support group for their perfect arrangement and ensuring the seamless experience with the hall support and excellent audio-visual support. Lastly, but most importantly, I thank all the faculty members, technical and non-technical staff, research scholars, participants, students, and organizing team who have worked tirelessly behind the scenes. Your dedication and hard work have been instrumental in making this event a grand success. Once again, I thank everyone of you for gracing this occasion with your presence and support. Let us look forward to enriching and engaging learning experience in days ahead. Thank you.
Thank you, sir, for your kind words and heartfelt gratitude. As we conclude this inaugural session, may I request everyone to rise for national anthem. We extend our heartfelt thanks to all other dignitaries, faculty members, and participants from various colleges for being with us today. Now, we invite you all to join for high tea just outside the Iris Hall. And dear participants, the session will be started with a lecture by Professor Hu, sir, at 12:30 p.m. sharply. So please come back to this hall before 12:30 p.m. And so, Professor Hu, sir, we should start the session by 12:30, sir. Okay. Half an hour session. Half an hour break, sir.
Okay. Right, half an hour.
Time.
Okay.
Time serial.
Yes, yes. Okay. Thank you.